This video follows on from the one in which we looked at atoms and elements. We learnt that an element is a substance made up from just one type of atom. When more than one type of atom is chemically bonded together to make a substance, we call it a compound. Most of the substances we see around us every day are compounds. Water, for example, is a compound made from oxygen and hydrogen atoms. The chemical formula H2O tells us that every water molecule contains two hydrogen atoms and one oxygen atom held together by chemical bonds. Unlike water, many compounds made from two types of atom have names which tell us about the atoms that are in them. The names of metal atoms come first, followed by the names of non-metals. It's very common for oxygen to be found additionally as a third type of atom in compounds, and a special naming convention is used to show this. Names ending in IDE show that additional oxygen is not present, while names ending with ATE show that oxygen is present, as well as the other named atoms. Sodium chloride is the chemical name for table salt. We see that the name contains sodium and chlorine, but the name ends in "ide", so there is no additional oxygen in the compound. Magnesium sulfate is used in bath salts. We see from its name that it contains magnesium and sulfur, and the "ate" ending tells us that it contains oxygen too. We can see how the names reflect the types of atoms from which a compound is made with these examples. Zinc sulfide contains zinc and sulfur, and the "ide" ending means no oxygen is present. Cobalt chloride contains only cobalt and chlorine for the same reasons. In sodium chlorate we can see that the ending is changed, so sodium chlorate contains sodium, chlorine and oxygen. The same is true for lithium chromate, which contains lithium, chromium and oxygen. Sodium nitride contains sodium and nitrogen atoms, whereas aluminium phosphate contains aluminium, phosphorus and oxygen atoms. Finally, we have potassium oxide. This contains potassium and oxygen, but there isn't a third type of atom present, so we use an "ide" ending rather than "ate", even though oxygen is present. The chemical formulae for these compounds show how the names correctly reflect the types of atom that are present. Don't worry about the numbers in these formulae, we'll look at what they mean a little later. When we have more than one type of atom present, but they're not chemically bonded together, we have a mixture. A mixture can be separated into the different substances it contains, unlike a compound, where the chemical bonds prevent us from separating the different types of atom present. A mixture could contain elements or compounds. For example, air is almost entirely a mixture of two elements: oxygen, which consists of molecules with two oxygen atoms bonded together, and nitrogen, which consists of molecules with two nitrogen atoms bonded together. Because the oxygen molecule is not bonded to the nitrogen molecule, air is a mixture of oxygen and nitrogen. We can draw blob diagrams to illustrate the atoms in elements, compounds and mixtures to make sure we understand the difference. This diagram shows argon, which consists of individual argon atoms. It's clear that this must be an element. The next diagram shows oxygen, which we have seen is made from pairs of oxygen atoms bonded together. Again, there are no other types of atom present, so oxygen is an element. The next diagram shows carbon dioxide. There are two types of atom present, so this can't be an element. The carbon and the oxygen are chemically joined together in the same way in every molecule shown, each one having one carbon and two oxygen atoms. This is therefore a compound. The final diagram shows molecules of nitrogen and molecules of oxygen, as well as a carbon dioxide molecule and an argon atom, all of which are present in air. There are four different types of atom present, so this cannot be an element. The atoms are not all chemically bonded together, with each molecule the same, so this cannot be a compound. Air is a mixture. A chemical formula tells us two important things: which types of atom are present in a substance, which is shown using the symbol for each type of atom, and how many of each type of atom are present. This is shown using a subscript number after the symbol for the atom whenever there is more than one of that type of atom present. This is why the formula for water is H2O. H for hydrogen atoms, subscript 2 for 2 of them, and then O for an oxygen atom, and no subscript number because there is only one oxygen atom in a water molecule. In the same way, the formula for tin chloride is SnCl4. The formula tells us that a molecule of tin chloride contains one tin atom and 4 chlorine atoms. It is important to remember that the first letter of any element's symbol is always uppercase, but many of the symbols consist of 2 letters and the second one must always be lowercase. This is to avoid confusion when we read a chemical formula. Every time we see a capital letter, it's a new element symbol. It's really important to write these clearly and correctly. For example, if we write capital P and lowercase b, we mean an atom of lead. But if we wrote capital B and capital B, then we mean an atom of phosphorus bonded to an atom of boron. In the same way, capital C lowercase o is the symbol for a cobalt atom, but capital C capital O is the deadly toxic compound carbon monoxide. Take the formula K3PO4 for example. K is the symbol for potassium, so we can see there are 3 potassium atoms. But what about PO4? PO is polonium, but that would be capital P lowercase o, and here we have capital P and capital O, so we have 2 different types of atom, a phosphorus atom and 4 oxygen atoms, not 4 polonium atoms. Finally, it's worth noting that we sometimes use brackets in chemical formulae, and a subscript number after the brackets. The number after the brackets means everything inside the brackets multiplied by the number outside the brackets. For example, the formula Al brackets OH close brackets 3 means 1 aluminium atom and 3 times 1 oxygen and 1 hydrogen atom. This is the formula for aluminium hydroxide. In the same way, the formula Mg brackets NO3 close brackets 2 means 1 magnesium atom and 2 lots of 1 nitrogen atom and 3 oxygen atoms, so 2 nitrogen atoms and 6 oxygen atoms in total. This is the formula for magnesium nitrate.